In this session, we are going to discuss about operational amplifier circuits. This will include integrator problems, differentiator problems, summing amplifiers, inverting and non-inverting amplifiers, differential amplifiers, adders, subtractors, the problem related to common mode rejection ratio, sensitivity, open loop gain, closed loop gain problems. Okay, for doing all this, we are going to use only one concept. That is the concept of virtual ground and Kirchhoff's current law. This is a symbol for an op-amp. It has two input terminals, that is a minus terminal and a plus terminal. This minus terminal is inverting terminal and this plus terminal is non-inverting terminal, and we get the output here. This is the output terminal. Okay, and we have two feedback. Suppose I am connecting in this way. This is a negative feedback. And suppose I have a resistor here, it will be R, and a source here. This is the input source. I am grounding this non-inverting terminal. We have a feedback resistance of RF. This is a negative feedback circuit. This feedback is taken from this inverting terminal. Now, what is the concept of virtual ground? We are assuming no current going inside the op-amp. So that is no current is going to terminal or no current is going towards this positive terminal. For an ideal op-amp, the input impedance is infinity. For a practical op-amp, it is very high. It is nearly 10 raised to 6 ohm or 10 mega ohm or more than this. We are assuming the input impedance, that is drawing here, that this is input impedance ZIN. Okay, this is infinity means no current will flowing to this terminals. No current flowing means potential at this point should be equal to potential at this point. So the potential difference between these 2 points, that is equal to 0. Difference 0 means no current will flow inside this negative or positive terminals. That happens when potential at this point, like this is VA and this is VB. So VA is equal to VB. Potential at negative terminal is equal to the potential at positive terminal. That is VA is equal to VB, or VA minus VB is equal to 0. VA minus VB is the potential difference between these 2 points. So that is equal to 0 means no current will flow inside these terminals. That is the principle of virtual ground. Now I am grounded this point. So VB is equal to 0. So potential at this point is equal to 0. So by using the principle of virtual ground, potential at this point should be also is equal to 0. So this is at 0 volt and this point is also at 0 volt. So no current will drawn inside this terminal. No current will flow to this negative or positive terminal in the case of an op-amp. In the ideal case, this input impedance is infinity, or in practical case, this may be some 10 mega ohm or more than. Then we simply apply Kirchhoff's current law for this node and also for this node. From that relation, we can find output voltage. Okay, so most of the problem can be solved by using this concept, that is potential at this point should be same as that of this point. If I am applying a potential of 10 volt here, 10 volt DC source, so the voltage at this point is 10 volt. So as to make the concept of virtual ground, potential at this point should also be 10 volt. So 10 volt minus 10 volt, the potential difference is 0. No current flow in this direction or in this direction. Suppose I am applying a potential of 100 volt at this point, then the potential at this point also should be 100 volt. So potential difference between these 2 points is 0 and no current will flow inside this operational amplifier. So that is a basic principle of operational amplifier. That is input impedance is very high. In the ideal case, the output impedance of an operational amplifier is equal to 0. In practical case, it has some very small value. Using operational amplifier for amplification purpose, it can be used as summer, it can be used as subtractor, integrator, differentiator, scaling amplifier, voltage follower, voltage divider, etc. So we are going to do the problems related to all this by making use of this single concept. It is a concept of virtual ground, and I am going to simply applying KCL at this node and this node. And I will obtain a relation between output and input, hence I can find output for any operational amplifier circuit. Okay, right, let us start. So we have an operational amplifier circuit. we want to find what is I naught. I naught is this current. Okay, choices are given. Now we are using the concept of virtual ground. That means potential at this point should be equal to potential at this point. No current will flow to inside the operational amplifier. And here a voltage of Vs is applied at the non-inverting terminal. So potential at this point should be the potential at this point. So this is also Vs. So potential difference between these 2 points is 0. So no current will flow inside the operational amplifier. Since there is no resistance here, this is a short circuit path. So potential at this point is Vs is same as at this point Vs. Since no current will flow inside this direction or this direction, so current flowing to this direction is 0. So this I naught will flowing in this direction. The potential at this point is Vs. So the current this is I naught. So I naught is equal to Vs minus 0. This is a ground potential. So minus 0 divided by Rs. So I naught is equal to Vs divided by Rs. So B is our correct option. Okay. So in this operational amplifier circuit, the input is given at the inverting terminal and the non-inverting terminal is grounded. We want to find the output after 20 seconds. And they are mentioning input is a unit step signal. Okay. Now we want to find the output after 20 seconds. Here also we are going to use the principle of virtual ground and apply Kirchhoff's current law at this node. Okay. Now the potential at this point is 0. So this point is at 0 volt. So by using the concept of virtual ground, this point is also at 0 volt. Okay. Now apply Kirchhoff's current law at this node. I am assuming all the currents are outgoing from this node. So this current going in this direction and this current will go in this direction. So this current is equal to 0 minus V input divided by this resistance. So 0 minus, I am converting this into Laplace domain. So 0 minus VIS divided by R. R is equal to 1 mega ohm. That is equal to 1 into 10 raised to 6 ohm plus this current, that's 0 minus V naught divided by XC, that is the capacitive reactance. So 0 minus V0S divided by XC. Okay. Now, what is the value of VIS? Since input is a unit step signal U of t, that is equal to 1. So VIS, that is equal to 1 by S. So this is a Laplace transform of unit step signal, that is the input signal. And our XC, that is equal to 1 by S into C. So this is equal to 1 divided by S into, the value of C is 1 microfarad. So this into 10 raised to minus 6. So we can write this is equal to 0. So we can write this is minus VIS divided by 10 raised to 6, that is equal to V0x divided by XC. This implies minus VIS is minus 1 by S into 10 raised to 6, that is equal to V0 by XC. So XC can be taken here. So this is equal to minus XC by S into 10 raised to 6, that is equal to V0S. Okay. V output of S, that is equal to minus XC. XC is 1 by S into 10 raised to minus 6 into 1 divided by S into 10 raised to 6. 10 raised to minus 6 and 10 raised to 6 get cancelled. This is equal to minus 1 by S square. In the inverse Laplace transform, we will get V0t, that is output is equal to the inverse Laplace transform of minus 1 by S square, that is equal to minus t. Output after t is equal to 20 seconds. So at t is equal to 20 seconds, V0t, that is V0 20 seconds, that is equal to minus t, minus 20 volt, that is equal to minus 20 volt. This is a voltage after 20 seconds. But we have VCC 10 and minus 10 volt. So V saturation is equal to either 10 volt or minus 10 volt. The output has maximum value either 10 volt or minus 10 volt. So it will never equal to minus 20 volt. So after 20 seconds, the output should be equal to minus 10 volt. Since Vsat is equal to minus 10 volt, that we given plus 10 volt and minus 10 volt. So the answer is option C, that is not option D. Okay, this is a previous year gate question. The question given that this OLVG, that is open loop voltage gain of an operational amplifier is 240. Okay, that means we have an open loop system with gain A is equal to 240. This will represent the output and this will represent the input. Okay, so open loop voltage gain is 240. Now the noise level of the output without feedback is 100 millivolt. So that given, suppose input is noise input. So disturbance input, let it is N of T, that is a noise input. And then the output without input due to this noise is 100 millivolt. Okay, so this is a statement. The open loop voltage gain of an op amp is 240. Noise is the input. The output is 100 millivolt. Suppose the system is a closed loop system with negative feedback and a feedback gain of 160. Then what is the noise level in the output? That is the question. Our system will look like we have an open loop gain A, that is equal to 240, and the system is a feedback, negative feedback system with feedback gain that B is equal to 1 by 60. Okay, so this figure will represent the system. Suppose N of T is the noise input and V0T, this is the output corresponding to this noise. Now we want to find the output of this closed loop system. In a feedback system, the noise or the output is reduced by a factor of 1 divided by 1 plus AB. Okay, due to feedback, the noise is reduced by a factor of 1 divided by 1 plus AB. So without feedback, the noise level is 100 millivolt. So 100 millivolt divided by 1 plus AB, that is the noise level if we are using a feedback having feedback gain B is equal to 1 by 60. So this is equal to 100 divided by 1 plus A is equal to open loop gain, that is 240 into feedback gain, that is 1 by 60. 240 by 60, that is equal to 4. So this is equal to 100 divided by 1 plus 4, that is equal to 5. So this is equal to 20 millivolt. By making use of feedback, the noise is reduced from 100 to 20 millivolt. So the answer is D. An open loop system is very highly sensitive to noise. In the case of a closed loop system, that is reduced by a factor of 1 divided by 1 plus AB. Okay. So this is a negative feedback operational amplifier circuit. Since feedback is given at negative terminal and positive terminal is grounded, input is given at the negative terminal or inverting terminal and non-inverting terminal is grounded. So the potential at this point is 0 volt. So by using the principle of virtual ground, the potential at this point should be also 0 volt. Okay. Then RF is the feedback resistance and R1 is the input resistance. The question is, we want to find the maximum possible value for R1. That is the maximum possible value of R1. If the voltage gain required is between minus 10 and minus 25. So voltage gain is from minus 10 to minus 25 is required. And the maximum value of RF, that is given as 1 mega ohm. So the maximum value of RF, that is 1 mega ohm, and voltage gain, that is AV, that is equal to V output divided by V input. This is lower limit is minus 10 and upper limit is minus 25. Okay, since this is an inverting amplifier, so the voltage gain AV is equal to minus RF divided by R1, since this is an inverting amplifier. So when AV, that is a voltage gain, is equal to minus 10, AV is equal to minus 10. So AV is equal to minus RF divided by R1. So RF by R1, that is equal to 10. This implies Rf by R1, that is equal to 10. So the maximum value of Rf, that is given as 1 mega ohm. So this implies R1 is equal to Rf divided by 10. Rf is equal to 1 into 10 raised to 6 divided by 10. 10 raised to 6 by 10, that is equal to 10 raised to 5 ohm. 10 raised to 5 means 100 into 10 raised to 3. 100 into 10 raised to 3 ohm. Or this is equal to 100 kilo ohm. Okay. Now, the gain is minus 25. That means Rf by R1, that is equal to 25. Since minus Rf by R1 is equal to minus 25. So, Rf by R1 is equal to 25. This implies R1 is equal to Rf divided by 25. Or this is equal to Rf is 10 raised to 6 divided by 25. This is equal to 100 into 10 raised to 4 divided by 25. 100 by 25, 4. So this is equal to 40 into 10 raised to 3 or 40 kilo ohm. So when gain is equal to minus 10, R1 is equal to 100 kilo ohm. That is gain is equal to minus 10. And gain is equal to minus 25. R1 is equal to 40 kilo ohm. So the maximum possible value of R1 is 100 kilo ohm. That is when gain is equal to minus 10. So C is the correct option. In this question, we want to find the input resistance, that is Vx divided by Ix, and the options are given. Okay. Now, the values of resistance is 10 ohm, 100 ohm and 1 mega ohm. And we are using the principle of virtual ground. So, potential at this point is same as the potential at this point. This point means this point, both are same. So, no current will flow inside plus terminal or minus terminal. So, this Ix will go in this direction. So, we want to find the ratio Vx by Ix. Point and this point are same points. So, the potential at this point is Vx. So, this point is also at Vx. So, the potential at this point at the negative terminal, that is also Vx. Okay, now apply KCL at this node. So, I am assuming current is leaving here and current also leaving in this direction. So, I can write Vx minus 0 divided by 10. That is the current in this branch. So, Vx minus 0 divided by 10 plus this current, that is Vx minus V output divided by 100, that is equal to 0. We can write Vx into 1 by 10 plus 1 by 100, that is equal to V0 by 100. Take the LCM, this becomes Vx into 10 plus 1 by 100, that is equal to V0 by 100. 100 and 100 it cancel. So Vx is equal to V0 divided by 11. Okay. Now similarly, the current in this branch, this current will go in this direction. So this current is equal to Vx minus V0 divided by R3. So we can write Ix is equal to Vx minus V0 divided by R3. That is equal to Vx minus V0 divided by 1 mega ohm, that is equal to 10 raised to 6. We can write V0 is equal to 11 into Vx, that is V0 is equal to 11 times Vx. So put V0 is equal to 11 Vx in this expression. So this become Vx minus 11 Vx divided by 10 raised to 6, that is equal to minus 10 Vx divided by 10 raised to 6. So this is Ix. So we get Vx. So from this expression, we get Ix is equal to Vx divided by 10 raised to 5, here's a minus sign, or Vx by Ix, that is equal to minus 10 raised to 5, that is equal to minus 100 into 10 raised to 3, that is equal to minus 100 kilo ohm. That is the input resistance. So the answer is B. So in this question, we want to find the voltage gain 0 by Vi, that is V output by V input. Okay. Now we are giving an input to the negative terminal and positive terminal is at ground. So the potential at this point is 0 volt. So by using the principle of virtual ground, this point is over at 0 volt. So potential at this node and this node are 0 volt. Okay, now we have another node here. Let this node be A. And the voltage at this node is indicated by V suffix A. Now I am going to apply KCL at node A. So KCL at node A. Okay, I am assuming all currents are outgoing current. This current is going in this direction, this current is going in this direction, and this current is going in this direction. So current going in this direction is VA minus 0. That is a potential difference for this branch. That is VA minus this voltage is 0. 0 divided by 10K. 10K plus current flowing through this branch. That is VA minus 0. This is a ground potential. So VA minus 0 divided by 1K plus VA minus V output divided by 10K. Plus VA minus V0 divided by 10K. This is equal to 0. So we can reduce this expression by taking the LCM. So all K get cancelled here. So this become VA plus 10 VA plus VA minus V0 is equal to 0. 1 plus 10, 11 plus 1, 12. 12 VA is equal to V0. Okay, now apply KCL at this inverting terminal, that is at this node. So I am assuming current is leaving in this direction and leaving in this direction. So current in this branch, that is equal to 0 minus V input, that is a potential difference, divided by 1K plus current going through this branch, that is 0 minus VA, that is the potential difference in this branch. So 0 minus VA divided by 10K, that is equal to 0. You can take the LCM, this K and K get cancelled, that is kilo get cancelled. So minus Vn into 10 minus VA, that is equal to 0. 12 VA is equal to V0. So we can put VA is equal to V0 by 12. So minus V in into 10 minus V0 divided by 12, that is equal to 0. Or we can write minus V input into 10 equal to V0 by 12. Or V0 by V in, that is equal to minus 10 into 12. That is equal to minus 120. So the gain is minus 120. Since input is given in the inverting terminal, so it is an inverting amplifier. So gain is negative. Okay.